So today we're doing 2.5. You actually don't need the graphing calculator today, but we are going to use it for some calculations. And as a follow-up from what we did yesterday, if you ever run into trouble where you can't graph something and you get any type of error, I'm going to show you how to reset your calculator because that's gonna solve a lot of your problems. Sometimes if you try to graph negative 2x, they'll say nope. Okay, and it says syntax. That means that most of the time you used a minus instead of the negative, and when you change it to a negative, it will graph that for you. Also, some of you had like your stat plot on, but you don't have any data points in there, so it won't graph it. I do have, oh no, I reset mine. So I don't think I have data points in here. So it says invalid dimension. So if you can either highlight this to take it off, and then you'd be able to graph, or to reset your calculator, if you press second plus 712, you'll get this screen. This is something that we'll do at the beginning of our test and at the end of our test with calculators. It will clear it for you. It'll put you back to a 10 by 10 window. Okay, so it's definitely something that we'll know. As you can see, I have it up on the board today because my other class had a test, and so they had to clear that. So you guys read through how to solve systems using substitution. Today we're going to solve systems using substitution and elimination. Okay, these are more methods to solving systems in addition to graphing that we did yesterday. So the first thing we're going to do is we're going to solve for one variable. Okay, it says in at least one equation. Really, we're just going to do that in one equation, and then we're going to substitute that result into the other equation. So just like you guys already did, you want to look for a coefficient of 1 or negative 1 if possible. Sometimes it's not possible, and that is okay. Okay, this would just be the simplest route. Okay, so you can always decide that. So we're going to solve that equation to get the value of the first variable. Okay, so I asked you to just do those first couple steps. So many of you did the first step where you took this equation, you solved for x by adding over y. Okay, and so you have x is equal, you can either write it as 3 plus y or y plus 3. Either way, same thing. Okay, and then step 2 is to substitute that into the other equation. So the other equation is the first equation. Now make sure you substitute it in for the correct variable, because sometimes that's a mistake I see. We just plug it in for the wrong one. So we want to plug it in for x. So instead of 3x plus 2y, I'm going to write 3 times 3 plus y. And what's really going to be important here with your practice is you going through these algebraic steps to just strengthen those skills. So we just have to know our order of operations. Once you've simplified everything you can in the parentheses, there's exponents, multiplying, which includes the distributive property here. Okay, so we're going to have 9 plus 3y equals plus 2y is equal to 4. Okay, now if you solve for y in the first equation, that's fine too. Your substitution would look a little different. Okay, so if you solve for y, you'd have y equals x minus 3. And then you could substitute that in for y. Okay, and you're going to end up with the same answers. Okay, so when we're combining our like terms, 3y and 2y make 5y. Okay, I'm going to subtract 9 from both sides. All right, and then that's going to give me y equals negative 1. Okay, so solve the equation to get the value of the first variable. Right, any questions for me up to there? And from there, now we're going to plug this in. Now it says to plug it into the original equation, and you can absolutely do that. If you've already solved for x here, though, I'm going to plug it in to this. So we have x equals 3 plus y, but instead of y, I'm going to plug in negative 1. 3 plus negative 1 is going to be 2. All right, and then, and so we just did the next step, so we're going to highlight that. So we substituted the value into one of the, it says original equations and solve. Okay, so if you wanted to, you could substitute it into one of the original, and I'll show you that that's going to work the same. Now, the fifth and final step is writing that as an ordered pair. Okay, and then you can also check your answer. So what I love about these problems is you can know before you turn your test in whether it's right or wrong. Because if those check, then you know that they're correct. Okay? So if you were to, I did this on this paper. If you, for step 4, if you didn't use this equation, if you wanted to use this equation to solve, you could plug in negative 1 for your y here. 3x plus 2 times negative 1 equals 4. And if you solve that for x, you would still end up with x equals 2. You could use this equation, plug in negative 1. Minus and negatives are positive, subtract 1, x is 2. Okay, so there's 3 different equations you could use to get the same result. When you are checking, you can just use mental math. The mental math you would do is you would plug in x and y. So 3 times 2 plus 2 times negative 1, and you would ask yourself if it equals 4. So this would be 6 minus 2 is 4. Yes. You do not have to write out these checks like we did before when that was part of the direction. Okay, this is just, like I said, if you want to make sure that you got this correct before you turn in your test, you could do this. Minus negative is going to be plus, so yes, that's going to be 3. Okay. All right, so for B, I want you to go ahead and do step 1. So I want you to pick a variable to solve for. All right, so looking at those 2 equations, what variable are we going to solve for in which equation? Yeah, we're going to solve for y in the first one. That's what I would choose. Again, you don't have to do that in order to be successful. All right, and then when you are solving for y, I'm actually going to add the y over, and I'm going to subtract the 3. Again, for a lot of these, there's more than one way to do that. So if I'm getting y by itself, I'm going to add y to both sides so that y is alone, and then I'm going to subtract 3. So this side is going to be 4x minus 3. Okay, once you find what you're going to substitute in, you have to substitute it into the other equation. So we used 4x minus y for this, so I have to use the second one. So I have 8x minus 2 times y equals 7. And do you see how I set that up? Like I put everything except for what I'm going to substitute in, and then I'm going to do my substitution. Okay, again, we're working on those algebra skills. So we have to know how to distribute with negative values. So we have 8x, negative 2 times 4 is 8, negative 2 times negative 3 is positive 6. And then something special happens here. You have 8x minus 8x. So that's going to cancel. So you're just going to have 6 equals 7. And is that true or false?
It's kind of false.
It is false. True or false is the question. So what this is going to tell you is if this is true, your answer would be infinitely many solutions. And if it's not true, which is the case we have here, what do we think it's going to be? No solution. Exactly. Right? So from yesterday, it's an inconsistent system. So no solution is what we write down. That's okay. Okay, so true or false. If it's false, we put a line through it. If it's true, I'm going to put a check mark there. Okay, so we still have the same things as yesterday where you can have one answer that's a point, you can have no solution, or if we do get a true statement, it would be infinitely many. Okay, now we can also use systems of equations to model real-world situations. So Latoya is making a total of 52 bracelets. And sometimes I read through this first and then go back and highlight. But it says that the total is 52, so I feel like that's something I'm going to have to know. So it's a total of 52 bracelets and necklaces to sell at a craft fair. Okay, each bracelet, so the bracelet takes 8 minutes to make. The necklace takes 11 minutes to make. And she spent exactly 7 hours and 44 minutes making the jewelry. So what we have to do is write a system of equations that's going to model this situation, and we're going to solve using substitution. So if it tells you how to solve, you do need to make sure that you use that method. Okay, so the first thing I like to do is understand what my different variables are. So we're talking about 2 types of units here, right? We have a total of 52, and that represents what? Yeah, your number of bracelets and necklaces. Okay, that's a total amount. What's another total amount that's given? What's the other one? Yeah, the time. Okay, so and the time to make. So what we're going to do is we're going to come up with one equation that represents the number of bracelets and necklaces, and then another equation that's about the time. Okay, we do need to define variables for this. Okay, so I'm going to use B for the number of bracelets. And I'm going to use Q for the necklaces. Just kidding. I'm going to use N. Do you guys think I laugh at the hardest at my own jokes? Because I'm going to say yes. Something like Q. You can call it whatever you want. Okay, so B is the number of bracelets, N is the number of necklaces. Do you guys think that you could come up with an equation that represents the total number of bracelets based on what we have? We're gonna do 2 equations. That's the go get 'em attitude I love. Alright, give it a try. So one's gonna be about the number of bracelets, one's gonna be about the time. Okay, so for the bracelets and necklaces, what did we come up with here? Yeah, what did we come up with it? Addison, what'd you get for this? No, just give me the first one. Good, okay, so B plus N equals 52. Great. Okay, so the number of bracelets plus the number of necklaces equals 52 total. Yay. Okay, now for the next one, I saw you guys did a nice job of using the 8 minutes and the 11 minutes. Okay, so with the bracelets, it's 8 minutes per bracelet. Okay, and it's 11 minutes per necklace. And what I'm modeling for you here is, even if you're getting lost in a story problem, do you see everything I've organized so far has just come from that problem? This is how you make an attempt visual, okay, instead of leaving it blank or writing IDK. All right, so we can start to organize some of that stuff. All right, so I saw some of you did a really nice job. You did 8B plus 11N. Now, 8 and 11 are both units of time. We know the total time is 7 hours and 44 minutes. So we do have to get that into the same unit. That's correct. So if it's 7 hours and 44 minutes, okay, you have the option if you want to convert from minutes to hours or hours to minutes, okay, but it's definitely going to be easier to convert everything to minutes since those are all in minutes. Okay, so for 7 hours, we're just going to multiply that times 60. 7 times 6 is 42. Put the 0 on there. Okay, so 464. Okay, so now we're ready to solve this system. Okay, so this is the system. I don't know why there's an S there. This is our system of equations. And then we're going to go to the solve part. Okay, so the first step is to solve one of these for a variable. Both B and N have a coefficient of 1, so it's viewer's choice. You get to pick. Okay? B. I chose N. But we can do B. Do you? I picked N. You do not have to do it. Do not be peer pressured. Or teacher pressure. Yeah, so feel free to solve for either one, and then let's see if we can get the same thing. Okay, and then once you have that, we're going to plug it back in here. I'm going to give you some time to do the algebra there. And, yep, you can use your calculator. I remember this. Oh, good. Yes. All right. So it looks like we're doing pretty good with the algebra. Again, these are where small mistakes happen on tests. So I like to give you that time to practice. So if we make a mistake in class, that's fine. We're just going to fix it. We're going to move on. That's definitely why we want to do this practice. And when you're adding and you get a negative here, you should have a negative on the other side because we're dealing with bracelets. And we want our answer to end up being positive. So when we divide that negative by the negative, the answer should be positive. So make sure you're doing those checks with yourself, like, does my answer make sense for this problem? So if you got a negative, you know, okay, that doesn't make sense there. Okay, and then for step 4, I would just plug this into the equation we did in step 1, 52 minus 36, and then we get 16. Okay, so the bracelets are 36, the necklaces are 16. When you are doing a story problem, instead of writing it as a point, you're just going to say what each one is. Okay, so 36 bracelets and 16 necklaces. And that's going to be incorporated in part B. So it says, describe what the solution represents in terms of this situation. I feel like we've been doing that almost every single time, right? Okay. So we got this. How many of each type of jewelry did LaToya make? And these questions are helpful because now as you're writing, you have something that you can incorporate into your explanation. So how many of each type did she make? And then this also says how many minutes did she spend making it? So right now we already know that she made 36 bracelets and 16 necklaces. So we can start with that. LaToya made 36 bracelets and 16 necklaces. Okay, and then how many minutes did she spend making each of the 2 types of jewelry? So, Caleb, how did you figure that out?
I just multiplied how many she made times how long.
Yep, so how many she made? 36. Bracelets, it said, took her 8 minutes. So we'll calculate that. And then the necklaces, she had 16. Those were 11 minutes. And then we'll calculate. Okay, and we are going to use the minutes in our answer, but I also am going to put in parentheses what that is in terms of hours. Okay, because we are not going to say that something took her 288, not inches, minutes. Minutes. Okay, that would be kind of strange for us to do. And I don't know about you, but like it would take me a second to compute that, right? Just like if somebody told me it was 35 degrees Celsius outside, I'd be like, am I wearing shorts or am I wearing long pants? It would take me a second. Okay, so we're just gonna estimate again. We're just gonna put that in parentheses for reference purposes. Okay, so yeah, so you guys already calculated it. How do we do that? You can just divide by 60, right? Yep. So she spent 288 minutes, which is approximately
4 hours, 48 minutes.
Yes, you could do that too. In fact, when we do some other things, I will have you do that, convert both. So I'm just going to say that's about 5 hours. So she spent 288 minutes, about 5 hours, making bracelets. And 176 minutes. And about how many hours was that?
About 3 hours, 2 hours.
Yep, good. Okay, so about 3 hours making necklaces. Okay, so that just gives us a better frame of reference, all right? Okay, great. Now, my favorite, elimination. What we have to do is we have to get rid of one of the variables. So again, I thought your book did a really nice job listing these steps out. So I took this grid right from your textbook. And as you're working through, feel free to look back at that. It looks like many of you remembered substitution, so that's great. For elimination, you are going to write the system so that like terms are aligned. And spoiler alert, most of the time they already are. So a lot of times you don't even have to do that step. And then you are going to eliminate one of the variables. Again, you choose. You can eliminate the X's or the Y's or the A's or the B's. Okay, it just depends on what you have. And once you do that, you solve for the other variable. This method also includes substitution, because once you find one of them, you are going to substitute that value back into one of the original equations to solve for the second variable. Okay, and then for all of these, you are going to write them as an ordered pair, and then you have the option to check that. Again, feel free to do that mental math. The check is not something that you have to write down for here. So when you're eliminating the variables, okay, rarely do they automatically cancel out. It does happen, and we are going to see that happen. But a lot of times, in order to eliminate the variable, what you have to do is you have to multiply to get opposite like terms. Okay, and that's for one variable. Sometimes it happens for both. When you're looking to do it for one, that's okay. That's a special case, and it does happen. Okay, but you're going to pick that for one variable. Then after you do that, you are going to add the equations. Okay, so after you eliminate one of the variables, then you are going to add the equations. So I'm going to just abbreviate EQ and S. Okay, you're going to add those equations together. Okay, so what we do is we look at the x's and we look at the y's and we see what's going to cancel out. This is one of those rare cases where you have negative 2x and you have positive 2x. So if you just add together from the start, you are going to have an elimination. The x's are eliminated, okay? The elimination is they're going to be 0. If you add 3y and 5y, you will get 8y. 7 plus 1 is going to be 8. And then we just have to solve this for y. So we're going to divide by 8, divide by 8. Okay, so those gives us, now we have y is equal to 1, and you get to pick which equation. It really does not matter. I just tend to choose one where I can avoid negatives where possible. Oops, I almost did that, but no, 2x plus 5y equals 1. A lot of times we're so used to plugging in for x, we want to substitute it in there. So I didn't need the parenthesis, but I almost made a mistake, and then I caught myself. So we're just double checking. We're going to plug that in for y. So I have 2x plus y, 2x plus 5 equals 1. And then we're going to solve this for x. All right, and then once you find your x and your y, you are going to write these as a coordinate. So all of your answers are going to be a coordinate point. Okay, so negative 2, 1. That's going to be your final answer. Okay, questions for me on that part? No, if you subtract 3, you'll have negative 2x equals 4. Yep, if you plug it into, wait, say that again louder. He said you were right. Okay, so if you minus 3, if I can't, you can't. Okay, and then you get negative 2. Yeah. Okay, now for the check, like I said, check can be mental math. Okay, if you're more visual and you want to write it out, you can. All you have to do is plug in the x and the y and then make sure they check. This is going to be a positive. 4 plus 3 does equal 7. Yay. 2 times negative 2 plus 5 times 1 equals 1. Negative 4 plus 5 equals 1. Yes, it does. Okay, so again, you can do your checks mentally. Okay, as in you do not have to write them down. Okay, but feel free to. All right. For part B, we don't have any that are automatically going to cancel out if we're going to add. So we want to make them opposite. So we have 3 and we have -6. The first thing I'm going to do is see if I can multiply something by 3 to get to +6, because you want them to be opposite. Yep, so you can multiply by 2. Now this is how I want you to write this out. So I know a few of you are working ahead. I just want to make sure you have these stacked up. So this would be 6x minus 12y equals 20. And then we're going to line this up as well. Okay, and then go ahead and add straight down. Yep, so if you add straight down and both of them eliminate, what are we going to write on that side of the equation? Okay, so you have 0 on the left side. What do you have on the right side? That cancels out too. So this is another situation where you ask yourself, true or false? And it is true. Okay, so if it's true, what are we going to write? Yeah, infinitely many. Great, infinitely many solutions. If it was false, then we would write no solution. All right, so why don't you guys give C a try? Feel free to try D too if you finish that one. All right, so when you are multiplying, I only wrote on that first one, like I wrote that we multiply by 2, and I only wrote it down on one side, but you are multiplying both sides by 2, okay? So you're distributing here and here, and then you distribute this one here. It's based on what you do to one side, you do to the other, that property of equality. When you guys are writing this out and you're deciding what to multiply by, which we should have decided on the top, you're multiplying by -2. I'm fine if you like distribute to all 3 there. Okay, and then so it has to be 3a times -2, 5b times -2, -2 times -2. And a lot of times if people miss multiplying by something, it's this side. Okay, so you can do that, or you can write it out both sides. Either one is fine. Okay, and then when you add straight down, the a's and the b's canceled. So you have 0 is equal to 5, which we know is not true. So our answer will be no solution. Okay, now part B is going to be twice the fun because we're going to do twice the multiplication because here you have 4 and 10. Is there anything here can I multiply anything by 4 to get to 10? Oh yeah, I guess if you guys want to do that, you can. And then if there's no whole number that multiplies to it, you can find a greatest common factor or like yeah, for 2, like maybe some of you were thinking, oh, 3.5. Yeah, you could do that. You could do 3.5, or you can also say, hey, 2 and 7 both go into what number? Yeah, so you could multiply the top by positive 7. Okay, so again, there's different ways that you can do this. So if you multiply everything in the top equation by 7, you're going to get negative 28m, negative 14n, and then 14 times 7 is going to be 98. 70 plus 28 would be 98. And then what I would have to do here is I would have to multiply this by something that would give me positive 14, which of course would be 2. So if I multiply everything by 2, I get negative 20m. 7 times 2 is 14, and this is negative 50. Now I have opposites. I could have also chosen like 4 and 10. If I multiply those together, you get 40. If you choose that though, do you see how they're both negative? Multiply one of them by a negative and one by a positive. So if you multiply the top by 10 to get negative 40, multiply the bottom by negative 4 to get positive 40, or vice versa. Okay, so you can choose. Your goal is to get opposite like terms. Once you have opposite like terms, that's when you add. Okay, so now that I have opposite like terms for the n terms, okay, and then we just plug that back in to find your n value. Yeah. I'll look at that in a second. All right, so some of you didn't plug this in, so let's plug this in. Okay, you can choose which equation. I just chose the bottom equation because it was on the bottom, and I could just plug this in here. And then just remember your little rules, right? A negative times a negative is a positive. With ones like this, it's usually something simple in the algebra realm that goes awry. Okay, so we just want to double check. And I am going to divide by 7. So a negative divided by a positive is going to be a negative. And again, just like we did with x and y, we're going to write this as a point. Okay, it's always going to be in alphabetical order. Okay, so this is MN. Okay, and I just write alpha order to remember. Okay, so anytime you have a system, I want you to write it like that.
If on a professor put it in the wrong order, will you have to mark off the point?
Yeah,
Okay.
and if you don't put it as a point, I will as well. Yeah, the coordinate. because M comes before N in the alphabet. So it'll always be an ordered pair in alphabetical order. Okay, so one solution is an ordered pair. Okay, we're gonna write X, Y, but let's write alpha order so we remember. The only time you don't have to worry about that is like during the story problem and you'll have your values. Okay, and then the types of solutions. So there's one solution, that's the ordered pair. The infinitely many is when you have a true equation, and no solution is when you have a false equation. Okay, so infinitely many has to have the same number on both sides. So you could have 0 equals 0, or you could have 5 is equal to 5. Either one of those would be fine. Okay, a false equation can be any two numbers that are not equal. So 0 can't be 5, 2 can't be 7. If you end up canceling things out, I don't want you to put no solution automatically, because if it's true, there's infinitely many, and if it's false, that's when there's no solution. Okay. All right, so I'm going to give you some time now to start this. 2.5.